Okay, I'm trying to demonstrate how to use atoms for your vibration absorber project. This is what atoms looks like when atoms view when you first open it. And what I'm going to do is to open an existing model that has the vibration absorber, which I believe is the starting point that I posted on Blackboard. So I'm going to pause for a moment and then I'll get right back to you. Okay, here I have opened up Blackboard, and if you scroll down, you look at the absorber project, and I realize that I did not post the absorber. So let me show you how to create the absorber. So I'm going to just get this out of the way and bring my atoms back over. So I'm going to pause and I'll start up again in a second. Okay, here we are back again. Atoms has just been opened up and I've just sized it to fit this recording screen. So what I'm going to do is create a new model. And up here, what I'm going to do is put it in a working directory. So you click on this folder and you browse to wherever you want to do it. I'm going to put it in here. You put it wherever you want to. The model name, I'm going to call it absorber, or let me call it no absorber. So this would be the building without the absorber on it. What you might want to do is pay attention to your gravity and your units. In this case, I've got millimeters, kilograms, Newton seconds. You can set the units once you start running atoms, but it's convenient if you pick the one that you're mostly going to use here. So I'm going to use this one: kilograms, newtons, meters, seconds, and degrees. The gravity is in the global Y. You can see the coordinate system down here. So you can see a little red X, and here's a green Y pointing up. And so it's telling me that gravity is in the negative Y, so it's going from the top of the screen to the bottom of the screen is gravity. We're going to put the thing in there with a constraint. Gravity's not going to matter. So anyway, I'm going to say OK. So it'll create a model. And at first there's nothing over here, and so you've got bodies that you can make. Connectors are like hinge joints and things of that sort. This is explained. If you say I don't get what a connector is, read the PDF file. I'm just going to show you some of the basics. So body, I want to create a mass, right? So here's a rigid body. I'm going to make a box. So I left click that, and then up comes this thing, and you can come over here. It's like a graphics program, and you just click and drag to whatever you want to do. I kind of like to make them a certain size, right? So what I'm going to do is just bring it over here and scroll it around wherever you want to put it. I'm going to put it over here, right about here. I'm going to attach my spring to the origin here. So just kind of keep my bearings. I'm going to put it right about there. So I'm going to left click, boom, I get this red box. One of the things that you have to be aware of is that where is this box, because it's going to be in 3D. So I'm going to come up here to see my scrolls, and so here you can see in the isometric, maybe the top view if you want to look at it. Oh, see, it's kind of off center. I'm going to try and shove it back because I want everything kind of, not that you need to, but you definitely don't want a spring going from one edge kind of diagonal. Anyway, I'm just going to move it back. So you can see that the box is selected because it's highlighted. If you click over here anywhere, see it's unhighlighted. I'm going to click over here. Okay, I've selected my box. And what I'm going to do is I'm going to move it. And I believe this guy right here is the move. So I left click on here and I'm going to translate it. Well, I'm going to move it, and these are relative to the screen, which you see. So it's 20 centimeters, I believe, from one edge to the other when I made it. So I'm going to move it 10 centimeters back. There we go. It's nice and centered now. So if you look at it in the front view, looks nice and centered. You look at it from the top. Yep. Look at it from the right side. Yep. Everything looks centered up. Okay. All right. So I've got a box. Now, this box is going to have properties, right? So it's going to have mass and et cetera. So if you click over here, you'll see that, oh, I've got a ground and I have a part number 2. Okay. Maybe you want to highlight this. I right click it and I say rename it. I'm going to call it the building. Let's see, that got out of my, there we go, drag it down here. Okay, instead of calling it part 2, I'm going to call it building. just so I can kind of keep them straight. Say okay, boom. So now it's called the building. And if you open this guy up, you have a box. You've got this thing looks like a coordinate system. It's a coordinate system is what it is. It happens to be the center of mass. So I'm going to use that to try to attach a spring here in a minute. But anyway, there's my building. And I'd like to know how much mass it has. So what I'm going to do is I'm going to come over here, right click, and I'm going to select the building, and I'm going to modify it. And so up comes this thing, and what I want to do is modify the mass. You can say I want to give it an initial condition or whatever you want to do. I'm going to change the mass, and I don't remember how much mass the thing said to do, but I'm going to say I want to specify the mass with user input. Okay, let's say, if you remember, this was, I think it's in newtons, kilograms, etc. So this number 62 is going to be 62 kilograms is the mass of this guy. I don't remember what our building is supposed to be. I'm going to say it's got 10 kilograms of mass. Whoops. 10 kilograms of mass. These things are your moments of inertia, and nothing's rotating, so it doesn't really matter what those are. So I'm going to say okay. So now I have a mass here that's got 10 kilograms of mass. Okay, if I were to run a simulation, F equal ma on this thing, what it would do is it would just fall, vertically downward, down the screen. So to show you how that works, I'll just come up here and I go to simulation. This little gear, and this is my simulation control. I'll simulate it for half a second, 0.5 seconds. And this is your, you've taken numerical methods, I assume. Whenever you're doing integration of differential equations, you have to choose a time step, and that's what this basically is. I like to choose time step rather than number of steps. And some of these other things, if you want to know what they do, you can take a look at the PDF. It's very powerful, much more powerful than what we need. Anyway, if I simulate this thing, what's this going to do? Well, it's going to fall down. So we say go, and in a minute it'll go. Room, and off it goes. Okay, so it's doing what it's supposed to. Well, I don't want my building to fall, obviously, so let me just kind of slide this out of the way. So what I want to do is I want to make the building go back and forth, right? So I just want it to go back and forth so that I have something that moves. Okay, so I want to attach a connector, and the connector I want is right here. You can see, maybe you can see it, maybe you can't. It's basically a translational joint, so it allows it to slide around in a direction. So I'm going to left click on that guy. And there's different ways that you can build it. Basically, I'm just trying to tell it which way, where is it, and all that sort of thing. So I'm going to tell it two bodies. So I'm going to put a sliding joint between two bodies. Okay, and then I'm going to pick some geometry feature that tells it which way to, the axis, right? So let's go down and take a look. Okay, so let me get this way out of the way. Let me just push it over here. Okay, so now you see my cursor's down here. Look down here on this right there. See it? Right, this guy. It says I'm building a translational joint using two bodies, one location. Select the first body. Well, I want my connector on the building. And now it says select the second body. Well, I want the ground. So you select anywhere out here, anywhere. See, it says ground, right? Anywhere out here, boom. Ground is the second body. Now it wants to know where to put the joint. Well, I want to put the joint right here in the center of mass. So I just get close and it pops up in center of mass, right? So I'm going to say I want it on the center of mass. Now, this is the direction that you want to let it slide. So for example, if it goes this way, it's going to slide on the left, diagonally up, left and up, right? That's not what I want. I want it to just go side to side. Okay, so I'm going to go right here, and I'm just kind of poking around till I find a there we go, center of mass Y vector. You see that? So I want the direction of the translation to be aligned with the center of mass coordinate system, the Y axis, right? So I'm just going to left click that, bang. So there's my joint. Okay, so what will happen is this building will be able to move side to side, but not up and down, not in and out. So now if I run the simulation, let me pull the simulation control back over. If I run the simulation now, what's going to happen? Nothing, because it slides side to side. Gravity is pulling it down, but the joint is holding it. So I've got a building that's able to move side to side. It doesn't look like it can move, but I'm going to put a force in there next. Okay, so let me rewind it. All right, there we go. And go back to building this thing. Okay, now I'd like to put a force on this building, right? This is going to come from the wind. Okay, so what we'll do is we'll come up here, forces, and I want to build a, this guy right here, create a single component force. In other words, a force in one direction that I'm going to apply to the building. This is going to be my wind. So I left click this. The force is going to be fixed in space. So for example, if you had a rocket or something and you're shooting, you have thrust out the back of the rocket, you want a force that's fixed to the body. So as the body moves, the rocket moves, the thruster goes with it, right? That's not what I'm doing here. It's going to be fixed in the ground. So it's going to be space fixed. And you can see the options that you have here. So space fixed, it's going to react against the ground. So the force always has to be between two objects. Well, it's going to be from the between the building and the ground is where it's going to come from. And the way I'm going to construct is I'm going to pick a feature for this thing, okay? And right now we'll just let the force be a constant. All right. And I click here and I say, okay, I want a force of maybe 1 pound, or the units are newtons, so this would be 1 Newton. Okay, so now I'm back over here and I'm going to create my force. And it says select the point of application. Okay, so the point of application is right there on the building center of mass. Okay, and now select the direction, okay, for the positive force. Okay, I want the positive force to go in the y-axis. So I just kind of, I'm moving it around, right? When I get close, it picks something. And well, I don't want it in that direction. Where do I want it? I want it, oh, here we go. Center of mass in the y direction. Boom. I must have clicked on something wrong. Okay, so let's try it again. Let's see. Yep, I don't have a force there. So let's go get it. Space fix, constant. Okay, there we go. It says, you see down there on the margin, it says select the body. Okay, I want the force on the building. Now it says point of application. I must have been talking too much. Okay, I want to put it on the center of mass. You can put it wherever you want to. I'm going to put it on the center of mass. Okay, now it's looking for the direction, right? So here I go, and that looks good. That's positive in that direction. So there's the S force. So if you come in here and right-click it and say modify, you get this little dialog box up, and okay, now I'd like to have a function. Well, we want it to be a sinusoid, right? So 1 times the sine of whatever frequency you want. I'm just going to say, 2 times t, whatever, something like that. So there we go. And you can type whatever. I mean, it can be as complicated as you want. Ooh, yeah, I need to put a times here. See, the yellow means I've made a mistake, so I'm going to say times. And that should do it for me. Well, or not. What the heck? Maybe it's, let me spell out time. Let's see, maybe that's, there we go. Okay, so it turns white. I've got it right. See this little dot, dot, dot? If you click that, you'll get a dialog box where you can actually say, you know what, I'd like the inverse tangent, and these are the things it knows how to calculate down in here. So you can do things like, well, I want maybe a data element. Okay, so I want no, that wasn't what I expected. Let me try, oh, here we go, like velocity. I want the velocity along x of something, right? So, that's how you can tell how fast it's moving or something. Anyway, you read the PDF and get more details. So now I've got a force. It's going to be a sinusoidal force. What should this mass do with a sinusoidal force on there? Will it oscillate back and forth, or what will it do? I'll bet you think you know, and I bet you don't. But let's find out. So I'm going to pull this thing over. Let's do it for half a second. So here we go. That's probably not enough. Let's make it 5 seconds. And off it goes, and it slows down. Then it speeds up again, slows down. Let's do it for some more, for a duration of another 5 seconds. See, it's not oscillating back and forth, is it? It moves a little bit, stops, moves a little bit, stops. You can see why that's happening if you kind of look at the theory of that. If you can't figure it out why it's happening, ask during class. I'll be happy to show you. Anyway, let's stop it. Let's rewind it. Get this out of the way. Let's change that force. So I'll right click and I'll say modify the force, and I'll put a cosine on there. Now what do you think it's going to do? Let's find out. Pull this guy over. Boom. Okay, this one's actually coming back, right? Probably should have had a larger force on it. See, so this one is oscillating back and forth. Think about it. See if you can figure out theoretically why that thing should happen. All I did was change it from a sine to a cosine. Okay, so anyway, there's my force. That's not really all I wanted to do. Let me pull it back and rewind it so it comes back to when I was building it. Okay, so here we are, we're building this thing. I want to put a spring between the building and ground. And that is with the forces up here. And you see this guy right here. This is I think this is the spring. Yep, spring. Hang on a second. My alarm's going off. I gotta go do something. I'll be right back. Okay, I'm back. So we're putting a spring on here, and you can, there's different ways to build it and that sort of thing, but I'm going to put in a spring constant of, and I know in the project it tells you what, I think it tells you what spring constant to use. I'm going to use a 1. And this will be in default units, which I think are newtons and meters. So there'll be 1 Newton per meter. That might be a little too wimpy, but anyway. And then a C, and the project says use of small damping. So I don't know what small is. So let's try 0.01. Okay. And then again, the units are going to be the default. If you want to put them in units, you can do, I'm not that good with units, but I think you put them in parentheses and you say, okay, spring constant is a force per length. So you can put, I think LB for pound per inch, I think would be reasonable. See if it turns, it doesn't like that, but it's something, look in the PDF file, but you can, maybe it's PLBF maybe for pound force. Anyway, you can specify the units that you want. But if you don't specify the units, you get the default that you selected when you first started. Okay, so here's my spring. So we'll come over here and let's see, I hit enter, and then I'll come over here and what does it ask me? Okay, see, I messed up. It's already got 1 point. I clicked on the wrong place. I'm gonna just gonna get out of here. Okay, fine, whatever. So let's try it again. So we're gonna do spring. We use these values. I come over here, it says select the first point. Okay, I want the spring between the building center of mass and the gravity over here. Select the second point right here. Boom. And so bang, I get this this guy. Now one thing I'd advise you to do is maybe look at the front and then also look at the top view, because if I had not moved this building back to the white line, what would have happened is I would have had a spring that was kind of at an angle, and it kind of messes up your calculations and everything else, because the spring is at some weird crazy angle, and things don't seem to be working. So anyway, you watch out for that. Make sure that isometric, yeah, it looks like it's all good to go. So we're back in the front view. Here's your spring, and I have this spring force on here, and you can simulate the building. So we'll say, okay, there we go. Let me really increase the well, you can see it's moving, right? Okay, and then let's say you want to make a plot, so you can go over here to the results, to the post processor, and let me see if I can size it to fit within this little window. All right, so there's certain things you can do over here. For example, you say, well, I'll right click on this and I say, you know what, I'd like to put, it looks like 3 views, 4 views, there we go. So I got 4 views, and over here, I would like to put the body, and I want the building, because that's the only one there. I want the center of mass. I like to put on this surf button here. So, I'll say, show me the X. I say, show me the Y. Show me the Z. Well, the Y and Z ought to be 0, right? Here's the X. Okay, so this is what without the absorber, that's what the building is doing. Then highlight this window, and we'll say, you know what, I'd like to see what the spring is doing. So here's this, here's that, the force that I'm putting on there. And I'm surfing, so let's see, X, there shouldn't be a Y, there should not be a Z, right? So X, yeah, kind of like that X force. Okay, and now down here, let's see, in this guy, I'd like to see the spring, and I'd like to see the force of the spring. Okay, so here's the spring force, and plot whatever you want to plot. In this window, you see how it's highlighted? I just clicked in it. And then up here, for the view, I'd like to load in the animation. So here's the guy. And you can use these buttons up here. I think this one here, I'm going to right click it, I think. No, let me try to right click this one. Yeah, there we go. I right click and I take this little magnifying glass, and then I hold the left button down and I can scroll it, making it a little smaller. Okay, and then I like to take this hand and kind of move him around to where, okay, yeah, I like that one. Okay, so here we go. And now when this window is highlighted, you can click the play button and you can watch the animation move while it moves through these plots and shows you the force at any particular time. It's fairly powerful. You figure out what you want to show. It has a recorder, so you ought to be able to kind of figure out how to record this thing. The reason it's important to do this is because employers have told me that they would like to have graduates that know something about, multi-body dynamic modeling. Well, that's what this does. So, fiddle with it, play with it, read the PDF files, see what other things you can do, but the amount of stuff I want you to do is fairly small. Let's see. So anyway, let's say I'm done with that. Thank you very much. And I'm going to go back to the model right here, this little gear, or you can close the window, but hit that gear, boom, you're back to this model. Okay, so that was the building with no absorber. What you want to do is you want the wind force to have a frequency that is pretty close to the natural frequency of the building. That's what causes the problem, is this disturbance force is close to what the building likes to do, and it just excites it and feeds energy in. Okay, so now what I want to do is create an absorber. An absorber is going to be another body. So, what you might want to do is save this. So we'll come up here, File, Save the Database. Okay, so this is no absorber. I'm going to go to the file, I'm going to say Save As, and I'm going to call it Absorber. Okay, so now this will be the second model, and it'll be the absorber model. Okay. All right, so I'm going to grab this and just kind of slide him over a little bit. Okay, there we go. The absorber is a body, so I'm going to left click this guy. I don't want it to, I guess you could make it the same, but I'm going to make it a little smaller. 10 centimeter, 10 centimeter, 10 centimeter, 10, 10, 10. Okay. And if you notice, I've ran the simulation and I don't have my grid or anything, so I'm going to come over here and say rewind. Okay, now I got my grid. Push him out of the way. Now here's the little absorber mass. Okay, I'm going to put him over here. I'm going to just kind of line him up. You can put him up here on the top. Who knows? I'm going to put him right about here. Boom. Okay, shows up green. Like I was saying before, look at the top view. Ooh, see, he's not really in alignment. If I were to attach a spring between the green and the building, it would be at some weird angle, and then all your calculations of deformation and they're going to be off, and so you really want to move him back. So what we'll do is we'll go here, and since he's 10 centimeters, I want to go halfway. I'm going to set this to be 5, and then boom, and he's back there. Okay, no problem. Let's go back to the front view. Boom, here we go. And now I want to put a spring between the absorber, the green absorber, and the red building. So I'm going to go over here to, I need to connect him up with a connector, because when you simulate him, you don't want him to fall down, right? So let's not forget the connector. So it's going to be one of these guys. And same thing as before. So I come over here, it says, okay, give me the first body. Okay, it's going to be part 3, which is, I probably should rename it. Now it says, what's the second body? Well, I want the building. So just anywhere in here in the building, right? If you go, you don't want the ground, you want the spring on the building. So come on, give me the building. There we go. Left click. And now it's asking me for the location. Okay, so well, I guess I wanted it. I was doing let me just, cancel. Okay, so put it on the center of mass, and then the alignment. Okay, so here we go. Center mass in the X direction. See that, right? So why it's in the X, who knows? But that's the direction I want. Boom, right there. So there's my joint. I should have put that joint on the ground, not on the building. I don't know what I was doing, so I'm going to delete that. So let's see, connectors. Boom. That's the second one most likely, right? Probably should have renamed it. I'm going to delete it. Boom, delete them. Let's try it again. Connector, bang. Two bodies, I'm doing the connector. I was thinking force. Okay, so part 3, the absorber, put it on the ground, locate it at the center of mass, line it up with the X. Boom, there we go. So now if you simulate it, the building's going to wiggle back and forth. This guy's not going to do anything. Okay, so now what I'm going to do is I'm going to attach a spring between this. So that's a force. It's this guy right here. And if you know what kind of spring force you want, great, no problem. I don't know if you want a large damper, you want a small damper. I don't know. Let's put no damping in there. Okay. And so now we're done with that. And so it says select the first point for the spring. Okay, well, I want it to be attached to the center of mass of part 3. Boom. Now it says find the second point. Okay, I'm going to attach it to the center of mass of the building. Boom. There's your spring. Let's make sure that it's not crooked or something else. Yeah, it looks nice and symmetrical. Okay, so there's your spring, and now let's run it. And of course, you need to know what kind of spring force to put and all that, what spring constant, excuse me. And so here we go, we're simulating it, and you can see that the little green guy is moving a little bit because of the spring. All right, so maybe you want to do it a little more or whatever. So, okay, so it's obviously moving, it's not really absorbing because you got to tune it. So you need to do some work and figure out what does it mean to tune an absorber. Okay, so there's my absorber. Okay, let me show you how to change things. Let's say you put the spring in there and you say, well, man, that was dumb. I should have had a different one. Well, right click over here on the spring and modify it. So here we go. Here's the spring. I want to modify it. You can change the stiffness. You can change the damping. You can, you can play with this preload and the default length. That's basically the free length of the spring. So you can adjust that if you want to. So just kind of dink around with it, but basically you're just going to change these values, and now maybe you know what you want to begin with, and you never have to change it. You know exactly what to put in there. Well, that's fine, but if not, you can adjust these things. So hopefully that makes sense, and then we'll just save it. And so we'll create a backup. Boom, it's saved. I've got these 2 files, and go for it now. And the real challenge, I think, is trying to figure out what do you want the damper, the absorber damper, the absorber spring. What do you want it to be? What number? How much mass do you want to set the absorber? You can just like you did here, you say, okay, I want the modify the part, and I'm going to define the mass by user input, and I'm going to make the mass 5 kilograms or whatever you want. So you can adjust the mass. All right, hopefully that makes sense, and good luck.